Hi folks, we're going to talk about how to do your reliability plan for your class project. I want you to first remind yourself of the different types of reliability that we've learned about. We have test-retest, split half, parallel forms, internal consistency, and inter-rater reliabilities, and each of these represent different ways of seeing if your test is measuring something consistently. So I want you to, at this point, remind yourselves in your groups what two forms of reliability your group is attempting to establish. Go ahead and look back at your reliability and validity plans. And then also, I want you to remind yourselves of the statistic that will represent each particular form of reliability that you're testing. If you need to at this point, you can go back to your book or go back to lecture notes that talk about the statistic that each of these forms of reliability relies on. And finally, I want you, using your books and note, to remind yourself of the cutoffs. In other words, what are your decision points? How will you evaluate the degree of reliability of your measure, given the statistic that you come up with? Once you've done that, we're ready to move on in testing for reliability. What you should do next is open your data file in SPSS. Okay, so I'm going to assume at this point that you've already got a clean, ready-to-go data file in SPSS. You should already have your variables named, any items that need reverse scoring reversed, and your data otherwise really ready to go at this point before you proceed. If you need some reminders of how to do that, recall the class project that we did in class for Study 1. And you can also go to that worksheet that we used in class. It's on Moodle, called Step 4 Item Analysis Worksheet. So if you go to Moodle, you can find it right here on our Moodle page. And it will download for you. Okay. So this is going to give you some information again about recoding into different variables and creating scales as you need it. So make sure that your data file is ready to go at this point before we proceed. Okay, so let me tell you a little bit about my measure that I'm going to use to show you how to test for reliability. I've created the Arousal Awareness Scale, and this is actually true. This is a scale that I created. And what I'm trying to do with this scale is to look at how aware males and females are of their physiological arousal symptoms related to sexual stimuli. So I created a 11-item scale on a 7-point Likert response. Let me show you what that looks like. Okay, this is what the scale looks like. You can see that I'm just asking people to rate how true each statement of each of these statements is of them. Okay, and you can see there's 11 items on that. Okay, so I plan to look at two types of reliability. I plan to look at internal consistency. I want to see how highly each of those items correlate with one another. And if I'm measuring something consistently, I should see high inter-item correlations. So if you recall, we're going to use Cronbach's alpha for that. Let's go ahead and do that now. So I'm going to open up my SPSS file, and here you can see I have the file available with all of the data that I'm going to need both for reliability and validity. Okay, and so to get a Cronbach's alpha, remember we go to Analyze, and then Scale, Reliability Analysis. Okay, and what I'm going to do is, you can see alpha is chosen here. And I'm going to pull over each of the items in the scale into the analysis window. Slowly, one by one. Okay. Then I want to hit statistics, and I want to know scale, descriptives for the scale, and the scale of the item deleted. That's all I want to know. And I'm going to hit continue and hit OK. Alright, and here's what I get. I can see in this, it tells me that I had 118 participants who had complete data. There was one person who had incomplete data, so they were excluded from this analysis. That's what that tells me. Okay, And here's my Cronbach's alpha. It's a 0.787 for my 11 items. Recall that we consider anything above a 0.7 acceptable reliability, but it would be nice if we could get above a 0.8. As close to 1 as possible is the best reliability. It's the best consistency. So what I can do is go down here to my item total statistics table, and I want to look first in this scale to see if what each particular item's correlation is with all of the other items in the scale. Recall that anything below a 0.3 is considered to be fairly poor, and it's potentially advisable to get rid of it. And my worst one here is item 6. So I'm going to go and look and see, well, okay, what's item 6? And here it is. I don't notice small changes in my body temperature. So for whatever reason, item 6, small changes in body temperature, isn't correlating as highly with some of the other items on this scale. And another way I can look at my decision to see whether I want to get rid of it is that if I delete it, this column here tells me what my alpha would be if I just deleted that item and kept all of the rest. And I can see that my alpha would go up to above a 0.81. And if you kind of look at all of them, really it's the most lucrative decision to delete it. And I might just choose to do that in the future, only because then I have a 10 item scale, and removing this one item gives me a really nice Cronbach's alpha, or internal consistency. Alright, so there we have done our Cronbach's alpha, and the second thing that I want to do is I've decided to look at split half reliability. So remember that split half reliability is when you take a single scale and you split the items into two halves and see how closely those two halves correlate with one another. There are several methods that you can use to do split half reliability. I've just chosen a simple odd evens item correlation. And so let me actually end the show now, that PowerPoint now, and go in and show you how to do that. Okay, so the first thing I'm going to do is I want to create a scale from the odd items and the even. So I'm going to compute variable. So I went to transform, compute variable, and I'm going to type in my arousal awareness scale evens. I'm going to create a new variable this way. And to do that, I'm going to just pull over my even items on my arousal awareness scale and add them together. Alright, so I have 2, 4, 6, 8, 10, and I'm going to click OK. And so this is just telling you it did it. And you can actually scroll over in your data sheet, and you can see now a new column that has the even items added together. Right? I'm going to do the same thing for the odds, so transform, compute variable. I'm going to reset here to get rid of the work that I just did, and I'm going to name it arousal awareness scale odd, and just pull in 1, 3, 5, 7, 9, and 11. Okay, and again, I'm just adding these together to create a single scale score from those items. I'll hit OK here. Again, this is just telling me that it completed that, and you can see now I have a column with the odds. So to do a split half reliability, I'm just going to look for the Pearson's correlation coefficient between the even items and the odd items. So I'm going to go up to Analyze and down to Correlate. Okay, and then a bivariate correlation is what I'm looking at. Okay, now you see that you have this window. I'm going to scroll all the way down because I want my even, AAS even, and my AAS odd. Okay, you can see that Pearson is clicked, and I do want that, so I'm just going to click OK. Alright, and here I have my correlation box for the evens correlated with the odds, and you can see that it is luckily a positive correlation of a 0.735. That is significant at the 0.01 level, and there is our R. So R equals 0.735. Now remember that when you do a split half correlation reliability check, we have to apply the Spearman-Brown correction. Because what happens when you use a small number of items to look at reliability in a split half is that the smaller items attenuate or bring down a correlation. So you want to correct for that attenuation given that smaller item pool by applying the Spearman-Brown correction. And here's the formula for the Spearman-Brown correction. It's R equals 2 times R divided by the sum of 1 plus R. And so if you recall, what I'm going to do that is I just grabbed my Pearson's R off of my SPSS output, and I'm going to plug it in here. So R equals 2 times, here is my Pearson's correlation, 0.735, and then I'm going to divide that product by 1 plus 0.735. And I've already done the calculations here, so 2 times 0.735 equals 1.47, and 1 plus 0.735 equals 1.735, so I'm going to take 1.47 divided by 1.735, and this is going to be my corrected correlation coefficient. So now R equals 0.847. Again, is that acceptable reliability? Remember that anything above a 0.7 is considered acceptable, anything above a 0.8 is pretty good, and here I have a split half reliability of an R equals 0.847, so I'm happy with that.